Hello, today I'm going to do a summary of all finance that you might find. Now this is particular for general maths in Queensland, but you might find this useful if you're studying finance for any exam. Now the first type of finance we look at is investments. Investments is you're putting money into a bank. This investment that we're first looking at is you're just putting a lump sum in the bank. There's no regular payments. And the suggested equation we have for this situation is below. A equals P bracket 1 plus I to the power of N. A is the total amount at the end of all the years or months that you're investing. So that's the total amount including the interest. And that's where the second equation comes in. I equals A minus P. A, the total amount, minus the principal amount, the starting amount you put into the bank. Could be $1,000 into the bank equal to P. You'll eventually end up with, let's say, 5,000 equal to A. So then you've got 5,000 minus 1,000 to get a total of capital I equal to $4,000. So this is the first type of finance question you could get. And this is for compound interest. So you're getting interest on your interest. That's what this first equation is for, compound interest investments. Now we could have some variation to this. For example, we could have just solving for little I, which is the interest rate. For some reason in Queensland we like to use little I for interest rate. And so we would have to rearrange this equation here to get little I, and it would look something like this. Another situation is given all the information, so they give you the end amount, they give you the principal, they give you the rate, and we need to find little n. So then we would rearrange it to get this. Let's try one of these variations now. So Shirley has $4,000 and she's wondering how long will it take to get to $8,000 if she invests into the account compound interest at 6% per annum, compounding every fortnight. So again, we use the compound interest formula. We substitute in. So this time we know what A is. That's the end amount. We substitute in the principal. And we need to substitute in the fortnightly rate. So let's convert I to fortnightly. Now, this is tricky. There are not 24 fortnights, there are 26 fortnights in a year. So we end up with a bit of a weird decimal. That's the fortnightly rate. And we don't know what n is. So the first step, we're going to divide both sides by 4,000, so you end up with that. Now this is where we have to guess. 8,000 divided by 4,000 is 2. So we're trying to put in n values. So if we keep putting numbers in, like we can guess, it's 2. So eventually you'll get n is 103. So you'll get approximately 2 equals 2. Now this is 301 fortnights. And we usually like that in years. So we're going to have to divide the 301 by 26, which is approximately years. So that's how long it's going to take Shirley. Now sometimes you'll get questions around compound interest or investments, and they say use the reoccurrence relation, and that's this one here, the reoccurrence relation. This is basically saying instead of using this fancy formula here, it's just trying to calculate the next month or the next year. So you're just timesing the interest rate plus 1. So R is the interest rate plus 1 times by the previous month or year. So if you start with 1,000, you just times that 1,000 by 1 plus the annual interest rate, and that'll give you the total amount for next year. So this takes a lot longer. And leads on to our second type of finance question, annuities. So this is investments or investment type questions, but we have payments and equal regular payments, that's an annuity, into the bank or into whatever the investment is. Regular, so if I'm doing $100 a fortnight into my bank account, term deposit, putting $100 in, this is an annuity. And we have some new formulas. So again, we could use the reoccurrence relation that I just talked about, but this time we're adding a plus D. This plus D is that $100 I'm talking about into the bank account at the end of each period, or like each month. The annuity formula is this one below. So some questions will say, use the reoccurrence relation. Otherwise, if you've got a payment, $100, you sub that in for M, you sub in interest rate, little I, and you sub in N. Another question you could get is, if I want to get $10,000, how much am I investing each month? So what's the capital M? So this is an example with a reoccurrence relation. Using this reoccurrence relation, you're subbing in the first amount. So after 1 month, you're going to have that amount. So you just keep doing this over and over again. So the second month, you're going to end up with that. And so if you just keep timesing by 1.00375, you'll end up in the 6th month, it'll be 51135.60. So it's gonna take 6 months for the investment to exceed that. And this is the reoccurrence relation. Interest on the interest plus interest on the original principal as well. So you could have a question like a reoccurrence relation for annuities, or you could have one like this. And this is where you could use the reoccurrence relation, but it's going to take quite a long time. So it's probably better to use this formula here. So if we substitute everything in, so we need to convert I to fortnightly. So if we do the conversions, and then if we substitute everything in, we get our final answer. So that's our second type of finance topic question. The third type is reduced balance loan. So instead of regular payments into something, to increase it, we're putting regular payments in to decrease it. So often this is a loan situation. So we're trying to buy a car or a house. And so again, we could use a reoccurrence relation, similar to the last two topics, or we can use this formula. It's often referred to as the present value formula. Again, the main two types of questions you could get is what's the total amount, what's the payments needed for a loan. And so this is when we rearrange this equation to get M by itself. This is the really useful thing about this equation, finding M, the payments. And so the banks you work with, they use this equation rearranged, so they bring this over to the other side. So let's do an example. So you've got a house loan, say for $720,000 at that interest rate over 25 years. What's the monthly repayment on your house? And this is taken from a QCAA paper. So you would use that equation I just showed you, substitute everything in, and rearrange for M, the payment. So A is that, and we're going to divide by all of this. Again, we have to convert N to monthly, and we've got to convert I to monthly. So substituting in all of this. So this is what you end up with, your monthly repayment of $4,126. And this could be useful in real life if you want to figure out what you're going to have to pay to the bank. You can use this method. This monthly repayment reduced balance question using the present value formula, it can also be worded like the one below as well. Mary's got an annuity and she wants to retire. How much income will she receive each month? So this is again going to use this formula here to figure out how much she's going to receive each month. So be careful, the wording can change. So this one, it was reduced balance loan. This one, it's find how much income she'll get from an annuity at retirement. We've only got 2 more topics left. The next one is called Perpetuities, and these are regular payments indefinitely. So an example of this is bursaries or scholarships. So you could have someone like this who wants to set up a scholarship fund. And so this is a very simple one, very simple formula. She's investing a perpetuity, so indefinite investment. So she wants to determine the amount if she invests a regular payment of $500. So it's a monthly income, so we need a monthly rate. So I is 6% divided by 12. So the monthly rate is 0.5%. So we're doing $500 monthly payment divided by the monthly rate. So she needs to invest $100,000 lump sum into an account, and that's going to generate a monthly income of $500 for her scholarship indefinitely. Final topic for finance, effective interest rate. Now this is more or less you are taking a compound interest given by a bank and you're converting it into a simple interest. So why are we doing this? Basically, we're just trying to determine what is the real interest we're being offered to make a healthy comparison. Because sometimes a bank will say, I'll offer you this compounding monthly, and another bank will say, I'll offer you this compounding fortnightly. And they're different rates, so it's hard to compare them. So to create an effective interest rate, use this formula. So we substitute in I, substitute in an N to get little I effective. So you can have just a basic find the effective interest rate question, or you can have a compare the interest rate questions as well. So I hope all of this helped explain the many different topics, finance questions you could have on an exam. And if you want to watch more of my videos, I've done many different types of these questions in different videos. Thanks for watching.